Hey everyone, PJ here. I'm going to teach you all how to solve a system of linear equations, two equations, two unknowns. We're going to use the method of difference of equations because it's quite visual. It's nice. I'm going to illustrate how it works, why we can find these two values, and then we're going to do it. So the first thing we're going to want to do is make sure that these equations are in the same form. So I want my y is here, my x is here, and then I want it equal to some constant. And this is going to be key for using this method. So if I go into these two equations, rearranging the first one, we can subtract 2x from both sides of the equation and get that form. So that's what I'm going to do. I'm going to go y minus 2x is equal to 1. And I just subtracted 2x from both sides of the equation, and I have y, some modifier, x is equal to 1. Then I'm going to simply rearrange this equation to put y first. And now I have both of the equations in the same form. Then I'm going to go to the multiples and make sure that at least one of these variables, preferably y, but it could be x as well, have the same multiple. And true enough, they have the same multiple and they have the same sign. This is positive 1y, positive 1y, which means this method is going to work now. Let's use green to represent y. We add y, this is equation 1. We add y, and then we subtract 2x. I'm going to use red for x. And if this is an x, let's say this is an x, we're going to take two of these, right? And we're going to subtract them from where we started, from where we ended up when we added y. Our equations tell us the point where we end up here is equal to 1. So this is equation 1. This is a visual representation of it. Now I'm going to visually represent equation 2, and you're going to see why taking the difference of these two equations will end us up being able to calculate the value of x. So here we go. I'm going to draw a green rectangle for y, same size, because we don't know what y is, whether it's positive or negative, but it must be the same size. And then I'm going to take these x's here, and I'm going to add 3 of them. 1, 2, 3 x's. What this second equation tells us is that the point we end up with here is equal to 7 units on our number line. 7 units. So we have these two pieces of information. Can we find x? We can do that because knowing that the y here and the y here are the same, which is why we have to have the same multiple and same sign on y, we can take the difference of these two equations, and this y, if I bring it down here, minus this y is going to be equal to 0. And that is going to enable us to completely eliminate y and only worry about the x's. We have negative 2x, so we're going to add that negative 2, and when you add a negative, you're subtracting. So we're subtracting 2x. And then there's positive 3x here, which we are subtracting. So when you subtract a positive, you have to subtract. We are subtracting these 3 x's, and we end up here with negative 5x. Our equations tell us this point we end up with here is equal to 1 minus 7, which is negative 6. And we have a negative 5 x's is equal to negative 6. We can rearrange to find that x is equal to 6 over 5. I hope it makes sense how we found this, just visually based on subtracting these two equations. I'm just going to replace the y that I stole from over here. We subtracted these two equations. By subtracting y from y, we ended up with y is equal to 0, and we found x. Next, we plug in x into one of these equations to find y. If I just rearrange this top equation back into its original form, we'll have y is equal to 2x plus 1. By putting 6 over 5 in the place of x, we find this. There we go. And by evaluating that in our calculator, we have 2 times 6 over 5 plus 1, which is equal to 3.4 or 17.5. So I would just say 3.4 here. And so here we've answered our questions. We know that x is equal to 6 over 5 and y is equal to 3.4. Or if they want them in fractions, this is just 3 2/5. 3.4. And we've solved our system of linear equations. I hope difference of equations explained like this is a bit more clear.